condition virtual object kept in a denser medium. Straight away, we'll try to conclude things because already we know a lot of the concepts. So, what do you mean by virtual object? What do you mean by virtual object? Where the rays appear to converge. If the incident rays appear to converge, then it should be a virtual object. So, what do you mean by virtual object? Where the incident rays appear to converge. So, this medium is rarer. This is denser. Mu2 equal to mu1 equal to 1. There's a boundary. I have to draw so many things. Yeah, there's a boundary. Fine. Now what will happen? We know the rays are moving from rarer to denser. So they should bend towards normal. So the rays here after refraction will bend and they will try to meet at this particular point. Okay, this will be virtual. This will be real. Okay, there's a boundary. So again, the same symbols, everything. Let this be angle of incidence I. Let this be R. Let this be I. Let this be R. Okay, no. So this is the ray. After refraction, they will converge at this point. So now the refracted rays, where they converge, that particular point of convergence will be a real image. When the refracted rays diverge from a point, the point of divergence will be virtual. How to identify the image real or virtual? In case of reflection, it was okay, if the rays diverge from a point, then the point of, if the reflected rays diverge from a point, the point of divergence will be a real, will be a virtual image. If the reflected rays converge at a point, the point of convergence will be a real image. In case of refracted rays, if the refracted rays converge at a point, the point of convergence will be real image. If the refracted rays diverge from a point, the point of divergence will be a virtual image. So as the refracted rays are converging at a point, so therefore this should be real. So who is the viewer? The viewer is here. So he is a eye. Is viewing it normally. So therefore for him, the object will appear further away from the boundary. So the same real depth and this will be the apparent depth. So what is apparent depth? Same derivation. So instead of deriving it, I'll directly write it here. So this will be mu2 by mu1 into HR, or this will be mu HR. So what is the conclusion? If a virtual object kept in a denser medium and when viewed from a rare medium, the virtual object will appear further away from the boundary. Similarly, here only, let me go for virtual object kept in a rarer medium and viewed from denser medium. So where is the virtual object? Virtual object will be there in the no. Okay, this will be normal. Normal I'll show by red cursor. Okay, now the rays are moving from denser to rarer. So what should happen to rays? The rays should bend away from normal. Oh, I to let me redraw it. Let me redraw it. So this is the real object. This drawing diagram is really very troublesome. No. So the ray is moving from denser to rarer should bend away from normal. So after refraction, so this is the virtual object. Virtual object. Real image. So this is P, this is N. Mu2 equal to mu, mu1 equal to 1. This is a rarer medium. This is a denser medium. Actually, the I must not be there. The I must not be there. It's about the refracted rays will not enter anywhere, no? So I'll remove this I. That is not needed. Okay, now what is the conclusion now? So where is the object? Object is in the rare medium virtual object. So you see the rays wants to converge at a point. After refraction, they'll meet at this point, particular point. The refracted rays converge at a point. So this should be the real image. So now what is the real height? The real height is this one. apparent height is this one. So therefore, what we can write here, apparent height is equal to mu1 by mu2 into HR, or HR by mu. So what is the conclusion now? So let me conclude these two here, because this conclusion will help us a lot in numericals. Virtual object kept in a denser medium, and virtual object kept in a denser medium and viewed from rarer medium, it will appear farther away from boundary. So the same conclusion, let me move this a bit here. Yeah, fine. Virtual object kept in a rarer medium, and when viewed from denser medium, it will appear nearer to the boundary. Okay, fine. So these are the four conclusions. Very, 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 very important. Hmm? So real object kept in a. So let me just briefly summarize. We have started from here, no? Complete page. Let it be visible. Yeah, fine. So now all of you listen. So these are the basics. This is not numerical. This is a theoretical background what we needed before going to numerical. Real object is there. You see the incident rays, they are diverging from a point. It's a real object. Real object. Hmm? So then after refraction, the refracted rays diverge from a point. So then the image should be virtual. Virtual image. So if the refracted rays diverge from a point, the point of divergence will be virtual image. Okay, then object kept in a denser medium when viewed from rarer medium, the image will appear. Oh, this is rarer. This is denser. So the object will appear near to the boundary. That's why it's called as apparent depth. HA will be less than HR. Next condition. Real object kept in a rarer medium and then viewed from denser medium. The refracted rays again diverge from a point. So therefore this must be a virtual image. This should be a virtual image, and this is a real object. See, the reflected rays, they diverge from a point. Though object is here, it will appear farther away from the boundary. And we have this particular formula. You have to remember. This is for real object. Next, virtual object. Virtual object kept in denser medium. Okay, what will happen? Where do it will appear? That one. It will appear. The depth will further increase. You can say mu HR. Mu will be greater than 1. So we'll get a real image. Virtual object kept in a denser medium, and when viewed means it will form a real image. So how do the virtual object, examples of virtual object, you just do one thing, take two laser guns, try to focus at a point. So we do that, they'll instead of focusing here, they'll get focused here. This is the idea. So how does, sir, we are not understanding